Using your own exception classes. An exception is an undesirable situation that can be detected during program execution. There are situations when an exception occurs, but you don't want the program to simply ignore the exception and terminate. For example, a program that monitors stock performance should request an appropriate action if the account balance goes below a certain level. Similarly, a program that monitors a patient's heartbeat cannot be terminated if the blood pressure gets too high. A program that monitors a satellite in space cannot be terminated if there is a temporary power failure in some section of the satellite. All of these programs must handle their exceptions. The code to handle exceptions depends on the type of application you develop. One common way to provide exception handling is to add exception handling code at the point where an error can occur. Until now, we have dealt with certain exceptions either by using an if statement or the assert function. Or in some places, you simply ignored the exception and the program printed an error message. This example shows what can happen if an exception, in this case, division by 0, occurs and is not handled. In the first sample run of this program, the value of the divisor is non-zero, so no exception occurs. The program calculates and outputs the quotient and terminates normally. In the second sample run, the value entered for the divisor is 0. Because the program does not check whether the divisor is 0 before dividing the dividend by the divisor, the program crashes with an error message. This example shows how to deal with an exception by including an if statement. The program checks if the divisor is equal to 0 or not, and if the divisor is not 0, then the program calculates and outputs the quotient. If it is equal to 0, then it prints an error, cannot divide by 0. In sample run 1, the value of the divisor is non-zero, so no exception occurs. The program calculates and outputs the quotient and terminates normally. In sample run 2, the value entered for the divisor is 0. Because the divisor is 0, the expression in the if statement fails, so the else part executes, which outputs the error message. C++ provides various mechanisms for handling exceptions, one of which is the try-catch block. Statements that might generate an exception are placed in a try block. The try block also contains statements that should not be executed if an exception occurs. The try block is followed by one or more catch blocks. A catch block specifies the type of exception it can catch and contains an exception handler. The last catch block can catch any type of exception. Suppose that an exception occurs in a try block and is caught by a catch block. The remaining catch blocks associated with that try block are then ignored. Therefore, you should be careful about the order in which you list catch blocks following a try block. Consider a statement that can generate an exception, for example, division by 0. Before executing such a statement, we usually check to see whether certain conditions are met. For example, before performing the division, we should ensure the divisor is non-zero. If this condition is not met, we can throw an exception. In order for an exception to occur in a try block and be caught by a catch block, the exception must be thrown in the try block. If no exception is thrown in a try block, all catch blocks associated with that try block are ignored, and program execution resumes after the last catch block. C++ provides numerous exception classes to deal with these situations. However, it does not provide all of the exception classes you will ever need. Therefore, C++ enables programmers to create their own exception classes. C++ uses the same mechanism to process the exceptions that you define as it uses for built-in exceptions. However, you must throw your own exceptions using the throw statement. In C++, any class can be considered an exception class. That is, an exception class need not be inherited from the class exception. What makes a class an exception class is simply how you use it. Now that the concepts are explained, The following example shows a user-defined class with no members to throw an exception. First, include the header file iostream, and then define the class div by 0. This class has no members. Next, you must declare the int variables divisor, dividend, and quotient. The try block starts here. This statement prompts the user to enter the value for the dividend, and this statement stores the value in the variable dividend. This statement prompts the user to enter the value for the divisor, and this statement stores the value in the variable divisor. Next, we type in the statement that may generate an exception. This statement checks whether the value of the divisor is 0. If the value of the divisor is 0, the next statement throws an anonymous object of the class div by 0. These statements should not be executed if an exception occurs. The try block ends here. Because the class div by 0 has no members, we cannot really do anything with the thrown object. Therefore, in the catch block heading, we specify only the data type name without the parameter name. The next statement outputs the appropriate error message. The main function ends here. In sample run 1, the value of divisor is non-zero, so no exception occurs. The program calculates and outputs the quotient and terminates normally. In sample run 2, the value of divisor is 0. Therefore, the throw statement throws an anonymous object of the class division by 0, which is caught by the catch block. It outputs the message division by 0. Next, we illustrate how to create exception classes with members. If you want to include members in your exception class, you typically include constructors and the function what. The definition of the class division by 0 contains two constructors, the default constructor and the constructor with parameters. The default constructor stores the string division by 0 in the variable message. The constructor with parameters allows users to create their own error messages. The function what is used to return the string stored in the object. In the definition of the class division by 0, the constructors can also be written as shown here. Now that we have defined the class division by 0, let us look at an example that uses this class to throw an exception. This is the header file iostream. The next header file is divisionby0.h, which contains the class division by 0. The body of the main function starts here. You must declare the int variables divisor, dividend, and quotient. Next, you must write the statements to input the dividend and divisor as in the previous example. Then you must write the statements that may generate an exception. This statement checks whether the value of the divisor is 0. And if the value of the divisor is 0, this statement throws an object of the class division by 0. These statements will not be executed if an exception occurs. The first statement calculates the quotient and stores it in the variable quotient. The second statement outputs the value of quotient. The exception thrown by the try block is caught and processed by the catch block. The parameter div by 0 obj in the catch block catches the value of the thrown object, and then uses the function what to return the string stored in the object. The main function ends here. In sample run 1, the value of divisor is non-zero, so no exception occurs. The program calculates and outputs the quotient and terminates normally. In sample run 2, the value of divisor is 0. Therefore, the throw statement throws an exception of the class division by 0, which is caught by the parameter div by 0 object in the catch block. It returns the string stored in the object and outputs the appropriate message.